safely as possible. As I mentioned, I'm targeting central Oklahoma, O'Keene. That's just north. Really, really good moisture on that. We'll dig into that shortly. But we've got a kind of a larger scale system coming in from the west with some good winds in the upper part of the atmosphere that are leading to lift. And at the same time, we've got this really juicy air mass coming in from the Gulf of Mexico, America, whatever your preference is. And it is going to interact with that system today. So we do expect storms. My only concern really is whether these storms will be isolated or if they're going to be kind of in a line. But otherwise, I think there's a very good potential for tornadoes today. Okay, so everyone can hear. Okay, fantastic. I really appreciate the shout outs, and it's always good to have a do-over audio portion too, because to be honest with you, that first audio was not as good as the second. So let's look into the meat and potatoes of this. So let me go ahead and find my screen, and I'll bring it up, and then we'll kind of dig into some of the weather today. So let me bring up my screen. So you can see there, I'm using the Weatherfront app. I don't know how many of you have used this app. I'm not getting paid for this, but gosh, this is a very impressive app. It has a lot of different things, models, satellite, radar, the whole bit, at the touch of your finger. So I figured this would be a great way to safely show you what I'm looking at as I'm going along. So as I mentioned, the first thing that I really like to look at when I am storm chasing, is I like to think about things in terms of a funnel, let's say. So a funnel, not coincidentally, obviously having to do with tornadoes, but really the idea is that when you look at a severe weather setup 10 days from now, let's say, you really know nothing about the details of that. It's all just kind of pretty much guesswork, and you're just doing your best to try to approximate where that might be over a region. Let's say you might know that there's a chance of severe weather perhaps over the central and southern plains, but that's about the extent of what you know. But as you get closer, you get more and more detail until you're finally a few hours away from the event, and you have a pretty good idea, like today, of where to find the severe weather. And so I break that down into 3 steps, basically, or 3 phases, and that's basically tornado forecasting, nowcasting, and targeting. So right now, I would call this the forecasting phase, because as far as I know, I haven't looked in just a second, but I don't think there are any storms going on right now. If they are, they're very new, so we can kind of dig into the forecast part of that, and then we'll go into the nowcasting part, which is when storms may be developing and you're trying to figure out which sub area within that larger forecast area that you should chase, and then narrow it down further in targeting phase to actually find the tornado. So let's dig into the forecasting part. So when I look at this, I really like to take a look at a larger scale model. So for me, I think the NAM is a very good, NAM, for those who don't know it. The NAM is a really good model to kind of take a peek at kind of the bigger picture to see what's going on. And so I'm going to switch to that here. And I'm going to move away from reflectivity to talk about upper air. And we'll go to 300 millibars, which is basically jet stream level. And the jet stream, of course, is about 25,000 to 30,000 feet above ground level where jets fly. And this is where most of the major players in severe weather really just get their origin. And you know, there's several different features like the Gulf and the desert Southwest, and kind of our position relative to the cooler air, you know, further north, that it all comes together basically over the plains every year to produce tornadoes. But we have a jet streak moving in, and you can see that here. Let me zoom out just a little bit further. And what I'd like to point out to you is really that we've got this big trough of low pressure up in the upper part of the atmosphere. And what that's doing is it's beginning this process of lead troughing, is what we call it. Basically, the air is rushing down the mountain in the rocky moisture from the Gulf. And at the same time, it's also creating these very, very sharp differences in temperature in the vertical dimension, which is then creating the potential for instability, which you would know in the meteorological jargon as CAPE. And so what I look for here primarily is I'm looking for sources of upper lift. So, and there are really two forms of upper lift. The first I would call is like straight jet divergence. So if you've ever heard of the four quadrant model, or you know, the left exit region, right entrance region, that's the first thing I usually look for. And so to identify that, you need to find a jet streak at, you know, usually 250 millibars or 300 millibars. And we do have one here. Let me see if I can get to the right time. This is actually 0Z, which is 7 p.m. local time in Oklahoma time. And you can see that we actually do have a pretty strong batch of wind coming in into North Texas and to southern Oklahoma, winds in excess of 90 knots. So pretty powerful for this time of year. And so if you split that into four parts, into basically four quadrants, you would have the left exit region kind of up here in, let's say, southeast Kansas, and then you have the right entrance region down in western North Texas. That's kind of the right rear of that, or if you have divergence there at the 300 millibar level, which is at the jet stream level, then it implies that you're going to have rising motion beneath it and lift for thunderstorm development, which is why I believe that in large part we did have that enhanced risk for western North Texas, right? So I think that's the primary driver at this level. There's something also I look for called ageostrophic curvature divergence. There's not much of that around them. The explanation for that is kind of tough to make on the road, but basically you look for where the trough out west kind of merges with the ridge out east, or basically the interface where they change concavity from concave up to concave down, if you can imagine. And right at that inflection point is where you have some rising motion. Now, we don't really have a very strong inflection point today, just because it's pretty flat, the flow at 300 millibars. So I would say mostly the straight jet contribution is going to be the player today, not that piece. But that's kind of what we're looking at for the time being. So I'm going to go ahead and jump back into the chats and make sure I'm tracking with everyone. So I'm going to hop off the view here and check into the chat. So allow me a minute to do that. Yeah, so we'll talk about the Kentucky risk. Obviously, that was a really terrible situation with the London tornado in particular. I've actually been to London. It's a nice town, and really sad to hear what happened there last night. That's actually only about 2 hours away from where I live in Tennessee. So it's just really sad to hear what happened to those folks. And absolutely, we are definitely sad to see what happened there. And unfortunately, there is a risk of more severe weather over the next several days, obviously, which is why I'm out here. And so definitely some other folks could be a part of that as well. Okay, so I'm going to get back into the forecast mode here, and we can kind of begin to talk about some other things too. So here, let me bring that back up. So we've talked about the 300 millibar flow. So we've diagnosed that at 300 millibars, basically the lift that we're seeing, kind of where the moisture is, and we'll look at the moisture here in a minute, is kind of over western North Texas at this level. But if we move down to 500 millibars, this is a layer of air that's lower than the one we just looked at. So maybe, I don't know, say 20,000 feet, something around that range. And so what we really look for here is jet streaks again. So basically areas of concentrated wind. So wherever the wind is strongest. So if you look at this in the risk area, let's zoom in a little bit, and you can see that over the SBC risk area today, which, by the way, let me just go ahead and hop over to that just so we can familiarize ourselves. I had a plan to do this, but it's like the Mike Tyson quote about everyone having a plan until they get punched in the face. And so I'm going to just deviate a little bit, and we'll go over to SBC's outlook quickly to talk through that. So you can see that they still have the enhanced risk out in the southern Oklahoma, North Texas area, with a slight risk kind of wrapping back to the north and to the west. The tornado risk is still 5%, I believe. I hope this is the updated day one, and maybe somebody in the chat can tell me. I'm going to flip to that real quick, so forgive me for bouncing around here. Okay, we come back here. Okay, so we have that 5% tornado risk, and it wraps up into northwestern Oklahoma. That's the area I'm looking at. You can see my little GPS locator there in eastern Oklahoma. I'm hopeful that the storms will kind of wait long enough for me to get there, but we'll see what happens. But basically, the moisture that we're looking at, the instability, all of that stuff is coming together over Oklahoma and Texas. So when we're looking for lift, we're looking for it kind of in the risk area. So I should mention that piece that I was talking about before, we're looking at that only from a standpoint of where it could possibly produce a storm that we'd be interested in. Because obviously there are lots of jet streaks in lots of places, and we're not interested in all of those. So we're only interested in the ones that we can chase. So we got that jet streak at 500 millibars, and what I really like to think about here, as opposed to at 300 millibars, is where you might have what we call vorticity advection. Vorticity advection is just like, basically, if you can think of air spinning, like you've seen that kind of bathtub whirlies, or in your coffee cup, or whatever, anything that spins in a liquid form or a vapor form. If you move that spin with the wind, that is called vorticity advection. Vorticity is the spin, and advection is the movement by the wind. And we see, how we diagnose vorticity is basically try to understand where there might be some spin in the atmosphere at this level. So you can see the jet streak here. Obviously, you got in southern Oklahoma, northern Texas, about a 50 or 60 knot jet max, which is actually pretty strong for this time of year. If you can imagine putting a paddle wheel in the middle of that, the north side of that is going to rotate pretty strongly. And so you're going to get a little curlicue on a counterclockwise fashion. So that would be essentially from, like, say, Dallas to Oklahoma City, and there's going to be a little bit of a counterclockwise spin in the vertical at this level. and that's what we would call a positive vorticity maximum. And so what we're really trying to look for there is, where is the wind pushing that invisible blob of air that's spinning from, Oklahoma City to Dallas. And if you look at the direction of the wind barbs here, you can see that wind is coming from the west to southwest. So the wind is blowing that spin into central and southern Oklahoma, and maybe arguably even into parts of northern Oklahoma. So I would say that is where I would expect storm development to occur, based upon what we would say 500 millibar vorticity index, or just the movement of spin. So that's the next piece I'd look at. So we've got a couple of lift components, or a few lift components that we've talked about. So we've got lift over, rising motion over the northern Texas Panhandle and over central Oklahoma. And now we want to look for basically wind shear. So wind shear is, obviously super important, but what's most important is to look in the lowest levels of the atmosphere for wind shear. So what I typically like to do to get just this general sense of what the wind shear will look like is I go down to 850 millibars. Let me zoom out a little bit. This is the layer about 8,000 to 10,000 feet above the ground level, known as the low-level jet, basically. So you have the upper-level jet, right, with the 500 millibar and 300 millibar jet stream winds, and then you have the low-level jet, which is closer to the ground, obviously, low level. And this is really the most important layer for winds for tornadoes. And typically what I like to look for here is winds that are on the order of, like, say, at least 35 here. 40, 45 knots are really good. 50 knots is incredible. Anything above that is just dynamic. And so what we're seeing here is a little less than that. So you see over southern Oklahoma, you see 20 knots, and you see maybe 30, 35. So it's a healthy low-level jet, but not a particularly robust low-level jet. So as good as today is in terms of instability, and we'll get into that, the wind shear is a little bit lacking, which is why I think the tornado potential is a little lower today than it will be maybe tomorrow or Monday. But nevertheless, because of the Cape, sometimes the instability compensates for the lack of wind shear. So we could very well see that today on our trip. So I'm going to go ahead and hop over to the chat again and see if you have any questions. All right. Sweet. Okay. I'm going to bounce back over to talking through the setup. And so let's go to the surface. So you can see I'm kind of starting at the top of the atmosphere and moving to the bottom. By the way, this is not at all comprehensive. This is just more a quick and dirty way of getting a view of the overall atmosphere that we have today. But we'll dig into some of the particulars in a little while. So what I'd like to look at is the surface, and in particular the 2-meter dew point and the wind barbs, excuse me. And you can see here from the NAM, it's advertising pretty well this basically influx of moisture, high quality moisture over North Texas and southern Oklahoma. So that is a really good looking pattern, I would say. As a storm chaser, you see this and you start thinking, that looks interesting. We see kind of this area that's kind of bent back to the northwest over western Oklahoma, and then maybe the hint of what we call a dry line bulge, where that sort of juicier air gets pushed back further east by the dry air. That looks pretty interesting to me from this NAM forecast. And then if you zoom in a little bit more closely, you can actually see that we have winds that are coming out of the southeast and even east-southeast. And that's actually really good for turning of winds with height. So when you're talking about ingredients for tornadoes, there are basically four major ones. There's instability, moisture, wind shear, and lift. And so this would be applying to the wind shear ingredient, which basically helps the storms get, rotation that produces the rotating thunderstorms that produce tornadoes. And what I'm looking for here is two things. We call them directional shear and speed shear. And so basically, directional shear is kind of like, as the name suggests, that's the kind of shear you have when you're kind of changing directions, like if you're spinning around. Whereas speed shear is the kind of idea that you have, basically stronger winds up top than you do below, and then the air in between starts to spin horizontally. That's speed shear. So in this case, we're not talking about speed shear, we're talking about directional shear. So if your winds are coming from the east-southeast, and remember, at the higher level of the atmosphere, they're coming from the west-southwest. So that leads to a lot of turning with height. And it leads to what we call storm relative helicity. So storm relative helicity is just a measure of the amount of spin available for thunderstorms to rotate. And today it's going to be on the lower to moderate side of things, but because of the directional shear, it's really helping with what could be a pretty low wind day. I would say there's a possibility that we could see some bigger stuff today based upon that directional shear. And that's also, by the way, not out of connection with the instability. We need instability too, and today we have that in spades. So let me just say that these dew points are just outrageous. I mean, you see here 77 degree Fahrenheit dew point is projected for southern Oklahoma. That is, even for this time of year, which usually has really juicy air, that's extremely juicy. And then you combine that with very unstable conditions. So let's look at that next. And so I'm going to go ahead and pop over to the convective side of things. So we'll go to severe weather, and then we'll go to Cape. And my goodness, look at that. So over North Texas and Oklahoma, the Cape is over 5,000 joules per kilogram. This is surface-based Cape. So sometimes that's a little bit of an overestimate, but really any surface-based Cape, over 3,000 joules per kilogram is just incredible. It's specifically once you get above like 4,000 or 5,000, that's like extreme instability. And what's amazing about extreme instability is that you don't always have to have really, really strong shear to go with the extreme instability to get tornadoes. Sometimes all you need is the instability. And so that's the kind of day we have, and particularly in May, it seems like from a climatological perspective, just looking at the calendar, the date on the calendar, these type of setups often produce tornadoes. So I'm not saying that's necessarily going to be the case, but I would not be surprised if we got some decent tornadoes today, particularly along the warm front. Okay, so I'm going to go ahead and get to the chat real quick and see if there are any questions. Just a minute. I'll put on this do not disturb mode here, if I can find it. Going to the chat here. So the question is about the app. What is the app called? It's called Weatherfront. So that just was released about 2 weeks ago, I'd say. And it's a very, very impressive app. So where are we headed? So hope you can see the tag there. I'm headed to Okeen, Oklahoma, which is just northwest of Oklahoma City. Any thoughts on Tuesday? I have not looked at Tuesday much, to be honest with you. I'll probably not chase Tuesday. It looks like it could be a good day, but it'll be in the sticks in, looks like in western Tennessee and sort of the deep south. So I've done enough of that this year, so I'll probably pass on that. But based upon what SPC says, it looks like this system's going to kick out and eject that day. And when it does, it could be pretty explosive. So I think there's reason to believe that Tuesday could be very, very big as well. So Eddie says that he's been feeling the dew points in the DFW area, no doubt about it. That's where that area you can wear is. Kent says, so would more shear plus high dew points cause strong tornadoes than low shear plus high dew point environments? So actually it turns out that it can go both directions. So sometimes you can get high CAPE with low shear that produces strong to violent tornadoes, and sometimes you can get the opposite. So, you know, it can go both ways. And another question, what are your thoughts on the Monday Oklahoma tornado risk? I would say it looks pretty big. My only concern is when you have these big trough ejections, typically you're dealing with, you know, a lot of storms. So even though the ingredients might be there, the instability, the wind shear, etc., it's sometimes the case that you get a lot of storms. And if you get a lot of storms, then you kind of reduce the potential for an isolated storm. So basically you have a bunch of storms competing for the same energy effectively. So that would be my concern for Monday. But taking at face value, you know, it's going to be a dangerous day, just like tomorrow. It's been my experience that days like tomorrow tend to be the bigger tornado days for, you know, storm chasers. So, I mean, days like Monday can be big for, you know, the general public, but they're typically difficult to chase. Whereas days like tomorrow typically produce, and they're reasonably good to chase, photogenic tornadoes and so forth. Oh, and then kind of a tornado chasing related question. Can you talk about how scary it was to experience El Reno personally? Yeah. I guess I haven't really talked about that in a while, but yeah, it was crazy. I put my video of El Reno on not that long ago. So about it was less than a week ago. And I watched that again, and it kind of brought all the feelings back. And I guess the best way to put it, you know, when you're experiencing it, is it's just almost shocking, like an out-of-body experience. I think the key moment there for me was when we were just south of El Reno on Highway 81, and we thought we had gotten away from the tornado. And I said, okay, we're good. And then all of a sudden I looked to the south of the big wedge, and the rest of the mesocyclone, which was absolutely massive, filled in to our southwest. And I realized that we were in big trouble. And so, yeah, that was by far the scariest tornado chase I've ever had. And I would say that, quite honestly, it's taught me a lot about trying to be safe and be respectful on tornadoes on days like tomorrow and Monday, and even to some degree today. You know, like, obviously every day you want to be careful, but there are some days where you have, you know, conditions, instability, wind shear, and so forth that are bigger than others. And El Reno was one of those days. It had CAPE of, like, I want to say it was 4,000, maybe 5,000, kind of like today, but it had wind shear that was basically 2 times larger than what we have today. So it's definitely an incredible experience. Very sad, you know, obviously what happened with TwistX. I knew those guys. I did a lot of work, quite honestly, after the fact to kind of investigate what happened and see how that came to be. And it was definitely a cautionary tale for everyone. Like I think it's really exemplifies. This is all extra compared to what I was wanting to talk about today, but really exemplifies, I think, a couple things that, a couple ways that it can go wrong for a storm chaser. Number one, really just rain wrapping around the tornado. That tornado was, very, very hard to see. And I know a lot of storm chasers like to get into the rain to see tornadoes, because it's like, if they don't get in there, they can't see it. But you risk something like what happened in El Reno, where you can't see the tornado, and then it pops out of the rain, and it's like right there with 300 plus mile per hour winds. And that's unfortunately what happened to Twist-X. And the other piece is really just like, I would say, it's easy to become overconfident when you have more experience, or, maybe you just don't know what you're doing if you haven't been chasing long. And so I think both kind of ends of the spectrum are dangerous. That's in part, to be honest with you, why I came up with the safety portion of the course for the online course that I built, which you can see the little lower left banner is associated with that. In fact, some of our course members are in the chat right now. But the idea is that, when the uncertainty is high, about what you're dealing with, you really want to take care to be cautious, to take a step back, to not get over aggressive. And I'm speaking from personal experience, and some of you who have followed me on Twitter for a while may remember my story from Cooperton, Oklahoma in 2012, and how basically I nearly got munched by a wedge tornado because we made a really dumb move by going into the rain. So I've learned a lot of this through the School of Hard Knocks. So definitely no judgment from me. I've been there, but I think it's one of those things where it is a serious business and you have to be careful out there. Okay. Yeah, Kent, that's a great point. Yeah, part of the problem with the car, you really want to get a four-wheel drive. I'm actually renting a four-wheel drive vehicle today, and that's definitely in large part due to that experience. I'm going to jump the gun a little bit on my process because, to be honest with you, I haven't checked actually what's happening in a minute. So I'd like to take a look at that with you all and see how we're doing from a standpoint of the actual weather. So we've been looking at the forecast. Now let's go ahead and pop up the screen and look up the actual weather. So I'm just going to go ahead and go to satellite. Okay, maybe not. Okay, maybe we have to go to a different channel. Let's go to... Okay, all right. So this is the veggie channel. To be honest with you, I don't even know what that is, but that's pretty cool. Veggie. Eat your vegetables. Well, it looks like western and southwestern Oklahoma that look like they could potentially produce severe weather. So maybe we'll pop over to radar here in a minute. One thing I wanted to show you all is we can look at the water vapor imagery. So let's look at mid-level water vapor. And let's see. Oh yeah, so this is water vapor imagery. So what this shows is like, it's not really like the visible spectrum. It's actually what you're looking at is water vapor and how it, because you can detect essentially. I'd like to point out here, and let's just go ahead and throw on the loop here, and you can see that we have clouds, kind of these kind of brighter clouds moving from southwest to northeast. And if you look really carefully behind these white clouds, you can kind of see that there's some kind of orangish colors there, kind of out by Lubbock. That is drier air. So the drier air is orange and the moist air is white. And where that comes together, that whole line where the motion is starting to increase, is moving into western Oklahoma and now into even parts of central Oklahoma. And so what I'd expect is that thunderstorm development ought to occur relatively quickly, because the ingredients are already there on a broad scale. I haven't looked at all of them with you, just given my attention limitations here today as a solo chaser, but I looked at it earlier, and we definitely have quite a few of the ingredients that we need. The radar. Let's see what we've got. Oh shoot, we do have a storm. Look at that. I've been out of the loop for a minute. Those storms are forming. So we are seeing basically the evidence of that rising motion. Now, with that rising motion is causing storms to develop. So what we just saw with water vapor is causing this storm to form. And look at that. My goodness. That's a nice mini supercell shape there. So we got that almost pendant shaped echo here. And anytime you see that on a day like today, that is a very fair sign for tornado development that would be coming soon. So I'm actually a little bit bummed I had to drive in from East Tennessee today, because I'd be right there if not for this long drive. But I'll be catching up a little bit later. Excuse me. My voice is cracking. Let me get a glass of water real quick. Okay, much better. Oh my goodness, look at that. Look how explosive that is developing. Just in a few frames, we went from basically nothing to, let's see, 55 dB, 0 to 55 dBz. That is evidence of very, very powerful instability, updrafts. And by the way, instability is correlated to updraft speed. So there's a formula that if you go to meteorology school, you learn about. I think it's like the vertical velocity, the air that goes up in a thunderstorm, is equal to the square root of 2 times Cape. Put on my nerd glasses to tell you all about that. But basically, because we have that extreme instability, that 5,000 joules per kilogram out there today, we're getting very, very fast moving updrafts. Very powerful. And this is the kind of situation that also yields pretty high hail to, baseball, softballs. So it wouldn't have big chunks of ice, which, by the way, is why I'm going to stay pretty far away from the core today. I like to anyway, but on a day like today, it's going to be pretty crazy. So, all right, I'm going to pop over to the chat and see what's up. Talk about El Reno. Absolutely, that was definitely the case there. I think Ken had the comment that the decision for Twistex to move east on Ritter Road was, or 10th Street as they call it, just south of El Reno, east of 81, was the fatal decision, unfortunately. And really, to be honest with you, I don't blame anyone who got caught up in that the way it was. That storm was wild. It, obviously was big. It obviously had, winds that were really powerful, up to off the record books. Up to 340 miles per hour. Howie Bluestein's group recorded winds that high, but they were not sure if the winds in the tornado were actually that strong. It was like, I think the official velocities they got were 301, unofficially 340. So everybody knows that, but what folks don't realize also is that or very few folks talk about, is the change in direction and speed of the actual forward motion in the tornado. That ranged from 0 to 60 miles per hour, and the tornado is effectively looped twice. So, it was, by far the most dangerous tornado I've chased. Okay, cool. So I've gone to the chat. Feel free to put more questions in there if you'd like to get some answers. So I'm going to kind of get down more to brass tacks with actual storm chasing here, because I'm a little bit late to the game today. I won't be late to the game tomorrow, so tune in tomorrow for kind of the full deal. I'll run through most of my process. There will be gaps, and by the way, that's perfectly natural. When you have a chase process like mine, it's meant to be intended to be comprehensive, so that you don't miss anything, so you don't make any mistakes. But on certain days there are pieces of the process that aren't going to matter, and so you don't really need to look. Just kind of drive in that general direction. Also limited a little bit by geography, because I'm kind of coming in from. Take a look at the full process. That's within my course. I actually do have a version of the course that you can look at. So it's not the full course, but it's basically what I call the essentials. That if you want to just take a peek, you want to take it for a test drive, and you're not sure that you want to really join, that's perfectly fine. There's a link in the description that actually gives you an opportunity to kind of take a test drive of the course and see what other folks have been looking at. And we've got a vibrant community that's also commented on that, so you'll see some of the comments there with some really great questions. So that's a really nice feature of the course as well. Our storm time of year. Towns that it's moving toward include Ninica, Lindsay, and eventually Blanchard, and towards Norman, which is crazy. That's the weather mecca of the world. And actually, I started my weather days in Norman. I got 2 degrees in meteorology from there, and so I have a lot of experience there. My folks still live in Norman, so I may have to check on them and see how they're doing here in a little bit. But interestingly, this is the same cell, I would say, that the HRRR had developed in a run a couple hours ago, and it had this thing kind of really intensifying as it approached central Oklahoma. So if the HRRR is any indication, we could see some tornadoes pretty close to Norman here in the next few hours. So let's put a loop on this, see how that's going. Oh, it's exploding even more. I saw some 60 dBz returns there, so that is absolutely explosive development. I will say that the storm is on the small side. Usually, given the amount of energy there is out there, this is early, that it could definitely do that, but it's a little itty-bitty guy. I don't think the cap is very impressive today, so I think there's a really good chance that the cap being the lid that suppresses storm development, just usually located about maybe 10,000 feet above the ground, maybe a little higher. That's not looking too strong today, so I think this will probably grow. And actually, some of the models had projected that this storm would get even bigger, or these storms would get even bigger. We're starting to develop almost a hint of it. We're already talking about potential development of hook echoes. So let's see how far away I am. I'm going to zoom out. We'll get a view of it eventually, in just maybe a while. So I'm over here in eastern Oklahoma. I'm making decent progress, probably better progress than I should be making. Going a little too fast, to be honest with you. Probably need to slow down. But I'll probably get there in, I'd say, maybe a couple hours. So probably shortly before 6 p.m. is what I'm looking for. So maybe on the southeastern side of Oklahoma City. These storms aren't moving too fast, I don't think. Let me go and check in on the warning on that. Severe thunderstorm, radar indicated. Let's look at the warning text. So quarter-size hail, and that's not too big. Motion, that's what I'm really interested in. Northeast at 35, so that's respectable. 35 is, I would say, it's chaseable, but it's a little bit on the high side. One of the things I talk about in my course is how to position relative to tornado, or excuse me, storm movement. So, you know, if you have a slow storm, you obviously can get a little closer. But if it's like moving pretty fast, you want to kind of maybe position downstream a little bit. In this case, we're kind of a little bit in the middle. And I think we're probably going to be okay to kind of just drive right up to it. So that's my plan based upon that storm motion. We'll see if it slows down. Sometimes these storms, when they start to rotate and become, and eventually when they become tornadic, they start to turn right and slow down. So that could potentially happen. Okay, I'm going to pop over to the chat again. So there's a question of, do you expect a lot of storm chasers chasing in Oklahoma on Monday? Yes, I would expect so. This is peak season, so I mean everybody and their cousin's going to be out for this one. And tomorrow will be no exception. Right. Apparently there's weather going into Dallas. We may take a look at that when we have a chance. Let's look at Southwest Oklahoma. That's a good idea. All right. So I'll pull up the radar again, and maybe we can, in Grady County, Oklahoma. Ah, yes, there's another storm. So we do have another storm close to Kingston, Oklahoma. It's pretty close to Ardmore, a little east of there. And it looks pretty similar to the one that's over there by Ninnekah. And then maybe we can pop over to the Dallas radar. Let's see what's going on there. Complex out there, kind of in western Texas, heading into the Dallas-Fort Worth area. But as you can see, there's a relative lack of storm organization going on here. Maybe a hint of a supercell there, but it overall kind of looks a little messy. That isn't to say that these storms couldn't become tornadic later. I think it's certainly a possibility, but I think overall the shear is a little bit lower in that area than it is in places further to the north. But what's interesting about that is that the HRRR had, the HRRR, which is a convection allowing model, had a storm or a set of storms that were going to develop in North Texas and then kind of spread to the east and towards the Red River, but really don't see any evidence of that just yet. So it's kind of interesting that it is a little bit less, there are few, let's say there are fewer storms than the model was depicting, which is not entirely surprising for the HRRR. The HRRR tends to produce a lot more storms than exist in reality. Okay, now we're looking at it from a different radar, so there's a little bit of an echo overhang is what they say. So it's pushing up and it's pushing out, which is why you get those anvil clouds. We might see a storm split here pretty soon. So storm splits basically happen when there's a little bit of shear available for storms to rotate clockwise. So typically with a tornado producing storm, you see in the northern hemisphere a counterclockwise producing storm, but sometimes they can be clockwise. It looks like that we might have that going on here. You can even check out velocity. That might be interesting to see what's going on there. I don't see anything in velocity that looks particularly suggestive of anything. There's lots of little blips there, but maybe some shear zones. We do the picture-in-picture here, I think. It's hard to hit that button. Okay. There we go. So here we go for that interesting southwest part of that storm. The shear there. Okay. There actually might be some shear there. So look at this. You got, so the radar is off to the upper right, is at KTLX, which is in Norman, Oklahoma, off to the northeast. and we have wind blowing away from the radar right there, very weak, and then you have a wind blowing toward the radar, which is that minus 37. The greens indicate toward the radar, so you can infer a little spin right there west of Rush Springs. So I mean, the shape of the reflectivity signature suggests that this is a supercell thunderstorm already. And then when you combine that with the velocity signature that shows air moving towards and away from the radar in close proximity near the area of highest reflectivity, it indicates that there is some rotation going on in this thunderstorm. It's very weak though. It might be interesting though to look a little bit higher, and so I actually might flip over to Radar Scope. I'm a little bit more familiar with the knobology of that, another program that I like. So I'm gonna, while I pop over to that, I'll look into the chat and see what's going on. Eddie says he's heading north. So Kent asks, how do you navigate when you're chasing by yourself? That's an excellent question. To be honest with you, I don't like to do it. Today is not my preferred way of chasing, mostly because I would like to concentrate on this, and for safety purposes, it is better to chase with somebody if you can. But if you can't, the best way to do it, in my opinion, is to select waypoints. And so what I mean by that, let's go to Radar Scope. Let me pull that up real quick, and I'll show you exactly what I mean. So I'm pulling that up now. That storm is getting really big. We may actually see a tornado out of this on this stream. I'm very optimistic about this. I'm trying not to get pulled over here, trying to obey the law as much as I can. For example, this one's moving 35 miles per hour, right, off to the northeast, and there's a little bit of guesstimate. Usually 30 minutes long, let's say. So you could say, okay, it's going to go, in 30 minutes, it's going to go the distance of that box, or like the eastern edge of that severe weather is going to hit that eastern edge of the box in about 30 minutes. So you can kind of get a sense for the distance, or you can use your distance tool on Radar Scope like I have here. So I think you can find it here. Yeah, there's the distance. So you can kind of see, like, I know I'm about roughly 2 hours away. So I might say, okay, all right, it's heading to the northeast. It might turn right. Okay, it's moving. It's probably going to slow down a little bit. So it's probably going to be around Peak or Shawnee. Maybe you can see that in the upper right part of the graphic. It's probably going to be at Peak or Shawnee by the time I get there. So what I would think about doing is basically you just go to your mapping software, and then you just type in Peak, or you just type in Shawnee, and then you just simply drive there, and you take out a little bit of the bandwidth issues that you see when you experience that. The bandwidth issues that you experience when you're chasing alone, those go away a little bit when you take that method, or when you use that method. So I hope that helps. That's kind of the way I'd approach it. Now, I'm very familiar with Oklahoma. I, up until 8 years ago, lived here basically my whole life, so I can basically drive these roads almost in my sleep. So I'm not too worried about getting to where I need to go, but that's kind of the approach I would use. Hope that was helpful. Okay, back to the storm. So this storm is around Rush Springs, potentially starting to spin. Let's go up in the tilt. So I like to use the storm relative velocity so we can account for the storm motion. Oh yeah, look at that. So this is a little bit higher up in the thunderstorm. I'm not exactly sure how much. Actually, we can check on that. Let's go ahead and check on that. So there's the Norman radar. If you have Radar Scope, you can actually do this pretty well. It's kind of nifty tool, but if you take the distance tool and you start at the radar and move outward, you can kind of feel find out how high the beam is, or the circulation is. So right there at Rush Springs, the beam height is about 7,800 feet above ground level. So what that means is we don't have much of a circulation near the ground, but, you know, nearly 8,000 feet above the ground, we're starting to develop what looks like a very probable circulation. And one thing I like to check on for this, and anyone who's been in my course remembers this, is looking out for fake velocity. Sometimes you can get sort of these phantom velocity couplets that kind of make you think that there's where this thing is. Okay, so it's kind of over Rush Springs. So my concern with this would be, in doing this check, is that if you notice where that high green velocity is on the top part of that radar view, that is in an area where, if you look at the reflectivity or how strong the thunderstorm is, that's out in the open. There's nothing there. So what this tells me is that there's parts of the thunderstorm higher up that have higher winds, and that there are parts of the radar beam out and it comes back and tells you something about the storm. Well, there's something called side lobes, and if you get a weak part of the storm having, you know, basically stronger storm above it, then the velocity signature from what's above it is attributed to what's below it. It's really hard to explain on the road, but bottom line is, you really, to trust that velocity signature, you really would want to see higher reflectivity or bigger colors in the bottom map there. So I'm not entirely positive that is it'll need some time. Okay, I'm going to pop back into the chat. Oops, I'm sorry, I wasn't showing my map. Sorry. Let me re-explain that. Apologies. So here's what I was looking at. So at tilt 3, we're about 7,800 feet above ground level, and what you're seeing here is what appears to be a circulation. You have the red next to the green, and I would think that maybe that storm is rotating pretty well, but I am concerned that may be kind of a fake out, that may not be a real velocity signature. So we'll see what happens with that. Okay, I'm going to learn to do this stream by myself eventually. Apologies for that. So going back to the stream. The snafu from just a second ago. So we'll try to make sure that doesn't happen again. All right, back to business. All right, so there's the thunderstorm. Let's take a look at some other thunderstorms and just see what's going on elsewhere. So I'm going to go ahead and go back to reflectivity just as the primary. And oh, by the way, this looks like it might be starting to split. You kind of see, if you look really carefully, and I think you can kind of do this, see, and kind of another one in the opposite direction. And so what I think is going on there is, I think what you're getting is a anticyclonic-cyclonic split, or splitting supercells. So this one, the southern one, near Rush Springs, will likely intensify and move to the east, or east-northeast. And the one to the north, in this particular environment, I'm not sure, I'd have to look at the hodograph and see what that looks like, but my suspicion that this one will probably not do as well as the one to the south. But anyway, that one's going to probably move a little bit more toward the north. So we'll see if that happens. So looking out the window, gosh, it's starting to have that tornado sky before you see a nice big event. We've got kind of these grayish blue skies that you see out ahead of developing thunderstorms. I haven't seen this in a while. I love it out here. Get these big anvils overspreading the area, and just really juicy air too that really makes you feel like there's going to be a tornado. Let's throw the loop on this one. one is really exploding in size. I think that's something that I think is really important to note here, is that when the storms get bigger, usually that means they have more potential to produce tornadoes. And that's because of a couple of things. One is that if the storm has bigger scale, then that typically means it can fight any dry air that's trying to erode the instability on the edges. So basically, you've got really dry air just above the surface in the cap level, and if you mix down too much of that dry air, it can reduce the instability. But when you have a really thick storm like we are starting to see here, it will reduce that effect, and so that, basically the storm can survive and thrive. And the other piece is that when you have a bigger storm, usually you start to accelerate the process of developing rotation in a storm. If you have a smaller storm, sometimes that can take a while to get going, really lending itself towards storms developing a lot faster. Okay, I'm going to pop over to reflectivity 1. Yeah, that is looking really healthy. To be honest with y'all, I feel like this is going to be an overperforming day. I think a lot of folks were worried that we were going to get a lot more storms today, and that was going to potentially ruin the tornado potential, and also that the wind shear wouldn't be overly strong. But I think we're actually seeing a situation where the wind shear may be starting to pick up a little bit higher than had been previously forecasted. And here's another nugget for you. So it turns out that, when you're talking about CAPE, when you're talking about, which is instability, when you're talking about shear, the easier one to get, the day of, is going, the day of an event, is wind shear. And the reason being is that very small changes in wind speed or direction can lead to very big changes in overall wind shear. But instability, the things that come together to make instability, come together over several days. So if you don't have instability, it's really hard to get it. But if you have instability, you can put together shear very quickly. So that's why, if you have a high instability day, my recommendation is not to blow it off if you have any chance of wind shear, because, that's why the saying goes, when it's May, you chase. When it's May, you chase, because it's very easy to find little pockets of wind shear among the sea of extreme instability. And that is a scale analysis here, so we can start to look at the environment and just see what's ahead of this storm. Okay. I'm going to pull up the SPC mesoscale analysis. Put that on the screen here shortly. Okay, hopefully you guys can see that now. So what I'm really wanting to look for is a couple of things. At this point, we're pretty interested in learning about where the favorable low-level shear is going to be. So I typically like to look for wind shear here. And, oh my goodness. Wow. So look at this. Effective shear right over this thunderstorm is 200 meters squared per second squared. To give you some context, the effective shear that you need for a strong tornado is really roughly anything above 100 meters squared per second squared. And that was kind of in the neighborhood of what we were going to be seeing today. But when you combine that with extreme instability of 5,000 joules per kilogram, maybe it lowers the bar a little bit. But when you're talking 200, that's wild. And even we have a little 300 bubble there. So honestly, I think today is starting to overperform. And I think that there's a chance that we could see not just a tornado, but tornadoes, and potentially some big nasty ones too. So I bet you anything that significant tornado parameter over that I like to look at this stage of the game Which, by the way, parameters are great, and you'll see people preach about this on social media all the time. Parameters are great, but they're no substitute for understanding how the atmosphere works, because parameters can mislead you. So I just really encourage you to dig into some of the data behind that to understand that. But yeah, that's something to keep in mind. Look at that. Wowzers. So that's an effective significant tornado parameter of 7. So just to calibrate you, if you don't know what that means, anything above a 1 means you have a chance of a tornado, roughly. Anything above a 3, maybe a chance of a strong tornado. Anything really above a 5, maybe strong to violent. 7 is there's definitely the possibility of a violent tornado. It's not saying that you're going to get one, but you're saying that the environment, the combination, by the way, this significant tornado parameter includes CAPE, low-level shear, lifting condensation levels, and the combination that produces that to get to the level of 7 is significant enough that warrants concern if you have an isolated storm of a violent tornado. So we'll see what happens, but it is May, so I'm again very optimistic about this for tornado chasing. A little bit worried from a standpoint of the folks here in central Oklahoma. Really hope everyone stays okay out here. Let's go back to the storm, and I'll pop that over here in just a second. So there's the storm. Now what's interesting is this storm looks a little bit less organized than it did before, so that's interesting. Let's put the loop on that. So it looks a little bit troubled in terms of the overall reflectivity signature. Seems to be coming down a hair, but the size is getting bigger, so I think those kind of counterbalance each other. I'd be interested in looking at higher tilts to see what's going on. Oh, it looks like we've got a dominant left mover in there, so that may be kind of holding back on the tornado potential for now. What you really like to see is a hook on the other side of the supercell. So we have one over near Ninnekah that's kind of anticyclonically hooked, and then you got no hook on the southern side, which is where you'd want one if you wanted a tornado. Not seeing that right now. So I think at this point we're gonna have to wait and see. And by the way, I know you can't see it because it's way too far away and it's hazy, but I have just started to see the updraft. So I can now, with my own eyes, see the updraft, and it's got a very crisp back shear on it, which means that the updraft is explosive. So hopefully we can get a better view of that with time. That's going to be off to the left there of the main image. Let's look at the velocity. Okay, so we're still dealing with pretty high velocity, but I think that probably is real because we're in the higher part of the storm. So let me just double check with the double pane. Again, we really like to see, if you see really high velocity, you really like to see reflectivity, or you like to see some reds, some yellows, some oranges where that is. And let's see, let's do the tool here. They have one for radar scope that I really like. Yep, the inspector. So look at this. So here's where the velocity is the biggest. Notice that the DBZ is actually pretty low there. So that's probably a fake wind velocity there, unfortunately. Oh wait, I'm at the wrong, excuse me, I'm at the wrong height. Let you try a little bit higher. Yeah, it still doesn't make a difference. So I think we may have some spurious velocity signatures. I'm gonna venture over to the chat again. So there was a question about Arkansas. I'm not really sure what's going on in Arkansas, but we can take a look at that. And then the time that the tornadoes could start today, I'm not really sure. typically situations like this can go one of two ways. You can get tornadoes really quickly, or you can, it takes maybe an hour and a half or two to get tornadoes going. And since this developed, I don't know, half an hour ago, my guess is that we're probably dealing with, maybe towards, let's say 6:30 or 7 p.m. for tornadoes to start forming. I think the site of that left split, at least with that target storm, that to me says we probably are going to have to wait a little while for tornadoes to form. So I'm going to take the target area of O'Keene off, because O'Keene is to the northwest of Oklahoma City, and it looks like this is going to be the east of Oklahoma City. So this is our target storm. And I'm going to go back to radar reflectivity. I'm going to go to tilt 1. All right. Interesting. Okay, so maybe this one is developing out in the. I need to put it up on the screen. It still seems to be developing out in the clear. So, is anyone seeing any reports of like wall clouds with this storm or anything like that? Put that in the chat if you don't mind. I'd be curious to know if anyone's seeing anything with this. I haven't been able to pop over to Twitter. I'd prefer not to do that on the live stream, just in case anybody objects. But if you see anything on Twitter, just let me know if you see any wall clouds or anything interesting. I think we were going to talk about Arkansas, and we may just pop over to some of the storms in North Texas as well. So we are definitely undergoing a split right here. Actually, I'm going to put the loop on real quick before I move on. You can actually see that the southern edge of this storm appears to be moving to the right, and the northern portion appears to be moving left. So this is a classic cell split going on right now, and we will likely see the southern storm intensify if it can survive the cap. I'm a little worried about that because the storm does look a little bit okay. There's some velocity there. Okay, so that's where I am. I'm just west of Henrietta. So I'm closing in on it. I probably got an hour and a half to go. Let's look at reflectivity. Yeah, nothing in Arkansas today, except way down there. I don't really know what's going on. Let's see. Let's take a look at that. Oh, I have to click off of this. So a lot of Cape out there. Supercells. Talked about a outflow boundary. So I suppose there is a chance of tornadoes down there. Not where I am today, but definitely something that could happen. Got the tornado watch up to the west. Let's see how this storm is doing near Durant. Okay, it looks like to me that some of these storms may be starting to decline a little bit, maybe owing to a stronger than expected cap. So that is something to keep in mind. That could be a failure mode today. These storms, and the reason I say that is because look at how tiny this storm is. East of Ardmore in southern Oklahoma, near Silo and Meade and Durant. That one is quite a bit smaller than you'd like to see. So I fully expect that storm to die, to be completely honest with you. Oh, no, we've got a new replacement. So that's not even the original storm. That's the replacement. So maybe there's a chance that could go up. But I do not like the small size, how skinny this one is. So that's good for the folks of southern Oklahoma. Let's hop over to Fort Worth. Was kind of partly what I was thinking earlier today, because I was thinking, oh, I'm going to miss the tornadoes because it's going to be in North Texas today. But when I looked at it more, I really like the bit back region of moisture, that kind of area of moisture that kind of goes back into northwest Oklahoma. Those east-southeast winds, it's a very good pattern for tornadoes, but you can start to see how that's developing out in central Oklahoma. Really, you're not seeing much of it in the way of signs of other storms developing just yet, although I think that should change with time as that system starts to arrive from the west that we saw in water vapor. All right, cool. All right, so I'm going to take a 5-minute break to call some folks. I'm going to give my family a call in Norman, so I'll put up the countdown clock, just let you know what my plans are, but I'll be back on shortly, so see you in 5 minutes. All right, folks, I'm back. Tornado warning for this storm, so I'm going to put that up on the screen here. Just a second. So we'll be there in just a minute. I've got another 45 minutes, an hour to go before I get there. So hopefully I can get there in time before anything big happens. But this is obviously the target storm. This is things happening very quickly. So this is actually happening earlier than I thought. I thought maybe by 6 or 6:30 we'd have a tornado threat. It looks like this is starting to rapidly evolve. So maybe it is actually more of the rapid evolving situation rather than the one that takes its time. So we'll see. You know, it still could be a little delayed, but I hope it's a little delayed because I don't want to miss anything. But anvil, very crisp anvil, a great sight to see as a storm chaser. Not as crisp as I've seen, which kind of, I guess, goes with the appearance on radar. It's a little wavy, not as strong as I've seen some supercells, but we've got time. But it does appear like there's a very powerful hook echo there. So let's zoom in on that and examine that. We've got a little bit of a traffic situation developing here. So let me concentrate on the road. That's first things first, safety, right? And then we'll go from there. So definitely an interesting appearance there to the hook echo. Almost a little bit of a knob at the end, almost like there is a tornado already. Although last I checked, right during the break, I checked, and it looks like there was just a wall cloud as of about 5 minutes ago. So I'm not thinking that anything's down just yet. We'll check velocity once I get through this tight road section. I want to keep my concentration up for this particular part. So I'm near Okemah, Oklahoma right now. If you know where that is, just off of I-40. The time is, let's see what is the time. It is 4:30 Central. Okay. Excellent. Bear with me for a minute. I'm checking a couple things. Okay. I may have to change some settings here for my juice. Looks like we are running out of juice for a couple of my... I'm sorry. Eek. Multitasking is hard, folks. The anvil is very crisp right now. Okay, great. I had a battery situation I had to work out. One of my plugs was running out of power, and I want to keep the stream running, obviously. So that's good to go. Oh boy, that is a wild-looking circulation. I'm going to go ahead and run back to chat real quick and see what questions that you may have potentially. Are the red dots different radars? Actually, those are storm spotters. So those are people who are out chasing the tornado, the coordinates for my next town. So I'll work on that while we wait. And I think it is moving to the right. So this one is probably going to be moving towards the area southeast or south of Shawnee. So probably what I'm going to try to do is is go down to St. Louis, Oklahoma. I didn't even know it existed, to be honest. And I'm going to put that in the phone. And I'm going to find my way over there so I can get some updates. Oh, I'm only 31 miles away, so I might get there before the show starts. 43 minutes away from St. Louis. All right. All right, putting the radar back on. Look at that anvil there, huh? Pretty nice. So at this point, chasing is kind of easy, to be honest with you. So, you know, on days like tomorrow, it's going to be hard because you're going to have lots of different choices. You're going to have 10 or 12 dryline supercells or something like that. And you're going to have to figure out which one to go after. And that can be a very, very tough decision. But on a day like today, it is very simple. You just go to the bubble. And that's what we're doing. I'm getting my camera going on my main camera because it is go time, so I want to make sure that gosh, I wish I had enough time to take the bugs off my windshield, but alas, there may not be enough time today. Hopefully tomorrow. By the way, I will be streaming again for the big event tomorrow and on Monday, so stay tuned for that, and I'll hopefully be better at this by then. Please forgive the lack of experience I have here. I'm just a noob at this, but I'll get better. And I'm actually enjoying it out here. I wish I had somebody to go with, but such is life when you're driving 14 hours to go tornado chasing. But I'm very grateful to be out here all the same. So looks like we have potential developing tornado. I don't know if that is actually happening. Let me look at correlation coefficient. So that doesn't seem to show anything. Correlation coefficient can show you if it had, let's say, a blue area where that red and green came together. Let's see if I can show it together. You might think that there would be a tornado there, but I don't see that happening right now, so I don't believe there's a tornado yet. Let's go right before that red and green come together. Yeah, maybe. Anybody seeing anything on any other streams or on Twitter as far as like tornadoes developing? We're getting really close. We'll have a view here, 45. So your time here won't be wasted, hopefully. You'll get to see it. One thing I do like, and I'm just going to kind of back out and talk about it, is I really like the clean inflow on this. We don't have a lot of thunderstorms around it. It's just, just one thunderstorm and there's nothing around it. So this is the type of situation, I'm being really frank, that like you can get like mega tornadoes from this. Assuming the cap doesn't, the drier air above the surface doesn't eat it, you can get really, really big time tornadoes. That's definitely a possibility that we get some big time tornadoes. I'm gonna go run back into the chat. By the way, I'm running on Starlink today, so hopefully that means that I will be having data the whole time. So, once I run it. Well, hopefully when other people come together and starts taking all the cell phone tower stuff, I'll still have data. Okay, so the question in the chat is, at what point in the chase day do you stop checking model runs? That's a good question. Typically when storms start to fire, really the best information that you're going to get is from, satellite, it's from radar, it's from surface conditions, basically observations of real weather rather than projected weather. But until you get to that point where you can actually see any meaningful observations, using model data is actually very appropriate. So at this point, the storm is there, so I'm not interested in models at this point. We have a real storm. Again, this looks a lot like what we had with the Her. The HRRR convection allowing model, basically a high-res storm model, has shown something like this, and it's right on track. So I'll be interested to see how this evolves. What do the differences in tilts on radar scope show? Okay, that's a great question. So the tilts in the radar basically show different angles that the radar is pointing. So if you can think about a radar having a beam, it sends out the beam at a particular angle, and those tilts correspond to the angle of that beam. So if you have tilt 1, that's the lowest angle possible, and then tilt 2 is above that, and then tilt 3 and tilt 4 and so on. So yeah, hopefully that helps. So basically, as you go up with the tilts, you're basically going higher up in the storm, if you can think of it. The Earth kind of, not only does the beam go higher, but the Earth also curves underneath the beam, so you're actually quite a bit higher up in the storm as you go up in the tilts. Good question. Is the best way to monitor cap on a storm you are tracking? I would say in real time, let's actually go over there shortly, and I can here. Hold on just a second. I'm getting some messages from my phone that if I don't change something up. So let me try something new here. I've been using the USB cords here, which work pretty fine, but I guess this particular thing that I'm using is quite intensive and definitely harder to get juice into your various devices. Okay, so we're exiting at Bragg and Seminole. Okay. Okay. Looks like we got some traffic. Okay, so I've got a little bit, hopefully stronger juice going into my main setup here. So I'm going to keep this stream alive if I can. And apologies for these technical difficulties. Noob experience here, so all right. So we're in Seminole now. Definitely been to this place quite a few times. Have seen a lot of tornadoes in these areas, not personally, but know of them. Okay. All right, now that I'm going in this direction, let's see what's in the chat. Okay, so good. There's no more buffering. That's great to hear. Guys, I hate to say it, but I'm a little worried that my system here is going to shut down, unfortunately. Just not able to that I'm getting from these. Just try one more thing. Hold on. That's why you don't normally do streaming. There we go. Let's see if that works. If I do go down, I will probably recharge and set that back up, but do apologize if that ends up going out. You don't see the radar? Okay. So it does look like this is going to wait for us a little bit, so that's good. Saw a report of a rotating wall cloud a little bit ago. Checking on my battery situation again. Our streaming camera is doing just fine. It's the iPad that for whatever reason is not drawing enough power from the power supply. So I'm hoping that we can get this thing going. If for whatever reason that dies, I'll restart. Okay, back to storm analysis. Okay, so we see this storm near Aaron Springs, Lindsay, Oklahoma. It's looking pretty good on radar. Not as good as maybe it had earlier with that pretty well developed hook echo. And let's check it out on velocity. It's still taking its sweet time, so I think the storm will actually probably wait for us, is what I'm thinking. Because we're really not that far away. Let me zoom out and show you where we are. So I'm that blue circle there, north of Seminole. But always better safe than sorry with this type of stuff. So too many times I've wanted to be a little bit more aggressive and get closer faster by heading west and then dropping south in front of the storm, and that can get you in a dicey position, particularly with hail. And on a day like today, you really don't want to deal with the hail. So, and once we get to St. Louis, we can probably head west and southwest towards the storm. Probably towards Wayne is my guess. Actually, let's see. Let's put the motion on this thing. I will go over to the reflectivity. Wow, that is moving to the right. Goodness. That's it's mostly almost east. So that is maybe even east-southeast. So this is making it a difficult storm to chase. I was hoping it would come up more towards me, so maybe this is the right decision after all. Dropping south a little bit earlier, you can see again, kind of backing out where we are relative to this thing. I was hoping it would come up more towards me, but it is obviously moving a little bit to the south. That may be an aberration, but we'll see. My power situation appears to be stable for the moment, so I'm optimistic that this will work. I think it may have been my power inverter just didn't have enough voltage. I thought it did, but it's I'd gotten so fixed up in this this thing that I failed to look at my battery. So another good chaser tip: make sure everything's charged. That is interesting. Starting to get a little bit more velocity next to each other. Not sure how well correlated that is, so interesting. Not very correlated, so it's hard to trust that. Another thing that we can look for is the spectrum width. Kind of a little cheat code there to understand whether the velocity you're looking at is legit. It just tells you like the range of velocities within a single beam, and that shows pretty high numbers. So I would say that it's very unlikely that that's a real velocity signature there. Okay, so this storm is looking interesting. We got zooming out. We do have looks like the left split going up there. Got a mesoscale into town. Always got to be mindful of that. If you've ever gone into these small towns, they'll get you. The cops will on the edges of town, so do need to be mindful of that. And really just trying to stay within the speed limit as much as possible. And we're almost there. So now we're in the town of Seminole. I'm going to look at my map and see what we're doing. Here's my real time. So in about 4.5 miles, I'm going to be turning up there, and this is going to take me towards St. Louis. So I'm just going to go through the heart of town here. Sometimes I like to look for ways to get on the other side of town that don't involve going straight through town. So there might be an opportunity, but at this point, don't get too cute. We'll just go ahead and go through town. So this is Seminole, Oklahoma. This was the site of a, remember for me, big tornado that was associated with the coal event. I'm getting old enough to where I'm losing track of events. That's interesting. So this one is still, could say a tornado looks imminent with this one. So let's see what our trajectory is for intercept. So I'm going to back out a little bit. So looks like we can probably intercept this based on its current trajectory, probably near Byers. So I'm going to go ahead and update my St. Louis bit to Byers. Oh, excuse me. And almost certainly at Byers we'll be able to see the storm. It's only 33 miles away. Another 45 minutes. This is unfortunately adding some more time to our clock because of the slowdown in the motion. Okay, I'm going to pop over to chat. I think actually before I pop over to chat, let me bring up the environment. Let's take a look at and see where we are with the environment. I'm going to pull up my browser and bring that up again. Okay, so it looks like this one is, let's see, when was it updated? 2100. So 2100 is almost an hour ago. So we'll have another one of these environmental views here in a minute. So let's look at that when that comes back up, and then I'll flip that off. Turn that off, excuse me. And then I'm going to go to chat. Thanks, Laura. I appreciate the encouragement. So Laura asked me, I asked about the decisions. Later, her runs for today look different from earlier. Yeah, for sure. And that's a real thing. There's zero doubt that there will be doubts. I think the thing I would say is that once you start seeing storms form, really what your analysis turns into is looking for signs that the storm you're looking at will produce a tornado, and that means like supercellular structure, clean inflow, higher velocities, and so forth. And we're seeing some of that. Think about chasing that, but this one is the best one around, so it makes that. Okay, I'm back. So sorry about that. Starlink dropped for just a second. Don't know why. But we are back. And let's look at the storm.
In 1 mile, turn right onto State Highway 59.
And gosh, the velocity just doesn't look that great right now, to be honest with you. Very interesting radar shape. I don't really like to see these wiggles, to be honest with you. You get the up and I don't really like to see these wiggles, to be honest with you. You get the up and the down and the up and the down and the up and the down. Left on the clock for sure. It's only 4:59 p.m. and so I think there's plenty of time for adjustments and things to improve. That's what we're about. Improvement
Turn
in
right onto
tornado
State
chasing
Highway 59.
ability and improvement in live streaming. All right. So here we go. We're turning.
For about 20 miles, continue straight.
We're on Highway 59. Let me just show you where we are. So this is just south of Seminole. So we're really getting close to actually getting a view here, and you can almost see that now. Dark sky ahead, and it's a little bit off camera here, but there is a view of the updraft on the left. It's not very crisp, which I don't like, and kind of looks a bit like I'd expect it to with that radar signature. Anyone seeing any reports of wall clouds or anything like that at this point? That would be a good sign, because at this point, if you're not seeing much on velocity or you're not seeing a great hook echo, oftentimes your first clue that things are going to start to ramp up is when you start seeing low-level clouds underneath a thunderstorm updraft start to feed into it, and you start to see big scud. Because usually that means that you're starting to stretch the spin in the storm. And if you've ever taken part of my course, you understand about stretch and spin, or even seen a presentation from me. Those are the two main factors in tornado production. So all the instability, the wind shear, moisture and lift, that's all necessary to produce the kind of spin and stretch that you need for tornadoes. So really what you're looking for is spin and stretch, and the atmosphere can kind of produce that in a variety of ways, but the most common way for it to do that is through a supercell. Oh, okay, that's looking a little better. I like that. I like that big blocky reflectivity signature coming out as it's kind of surging a little bit. That looks promising. It's still not looking great, but the higher reflectivity, the surging reflectivity, that looks good to me. I'm going to pop over to my map here and see what I'm looking at. So we got 18 miles to go, so looks like we're just going to stay on this road for a little bit. Okay. So it looks like it's near Maysville. All right. I'm going to go over to the chat very briefly. So we're southwest of Seminole. Oh, you can hear my map directions now? Oh, thank you. That's good to know. I might try to turn that off. Let's see. Not really sure where to toggle that off. Spoken directions. Here we go. I'm going to do softer volume on this just so I can hear it. To be honest with you, I probably need it a little bit since I'm not with anyone today. So But appreciate you calling that out, Laura. Oh boy, that is, let me put the radar back up. So this is definitely turning right. So the importance of turning right, you know, in addition to slowing down and showing intensification, is just this idea that when you turn right, you also change the nature of your hodograph. And your hodograph is something that determines basically the character of your storm, what kind of storm you're going to get. And I honestly would love to look at one right now to know exactly what we're dealing with. We may end up going back over to Weatherfront and taking a look at the hodographs there just to see if this would be favorable. But that, actually, even from just a hook standpoint, you don't really need to look at that to know that that's favorable. That's looking a lot more meaty, a little bit more beefy. So I would say that this is a good storm. Starting to get a lot better. Not an amazing storm yet, but a good one. So that's where I am, kind of approaching the Maud area. So I will very shortly have a view. Take a look at this velocity. So the velocity is interesting because I really don't see anything that looks spectacular just yet. So more the supercell shape that looks good. Sometimes that great shape precedes the actual event. And one thing I need to consider too is filling up. I've got about half a tank of gas. So I filled up in Fort Smith, but I've been driving ever since then. So at some point I will need to take a pause in the stream to do that. Won't take too long, maybe 5 minutes. Probably will want to do that in Maud. So that's always a good thing to think about as you're storm chasing, is gasoline situation. I did get a rental this time around that honestly I wish I would have gotten something else because it had like a 14-gallon tank, and I think if you get a bigger tank, that's better, just so you can kind of stay healthy and chasing for longer. So, yeah, Maud's probably going to be the spot for me. Because once we get into the forward flank of this, it's going to get pretty rainy. There's going to be lightning, so I'm probably going to have a break here in the next few minutes, and then we'll get back on. But we'll keep it on until such point as that happens. Yeah, there was a story from 1995 about, you know, the big June 8th day, the big Pampa, Kellerville, Allison Day, F4s everywhere, F5s, and a bunch of storm chasers were not able to continue chasing one of the big tornadoes because they ran out of gas, and then they were stuck in the panhandle until the power came back on. So it's also something that, then the reason or not again, but just to say that the reason that the power was out was because a tornado had hit it. So always good to be gassed up if you can help it. So I'm actually going to turn this off real quick with the radar view and try to find where I can find gas real quick. I don't really see anything obvious here, so I'm just going to see if I can find a gas station here. It should be. Yeah, there's a Sinclair right ahead. So I will stop here in the center of town for that. So let me get back to the radar. Oh, that's looking amazing. Well, folks, I think this has got a good chance to do something just based on that reflectivity. How that curves just looks incredible. I'm going to slow down as I'm going into town here. Classic Oklahoma scene ahead of a big, significant storm. I think Maud will be a little bit out of the path, but definitely areas just to our south. Okay, so I'm going to take a pause on the stream for about 5 minutes while I can fill up on gas. So about 5 minutes. All right, getting back on the road here. Leaving town of Maud. Okay, let's see where I'm going first. Really important to know. Okay, so I'm gonna stand by here and figure out where the storm is going. Looks like it's going towards Stratford, so I'm gonna go towards Stratford. I'm sorry, get out of the way here. Very difficult to do this all by yourself, I'll say that. Not ideal. All right, so I'm starting my route to okay. Great. Okay, so I think I need to reshare my screen, my iPhone, so just give me a minute while I'm trying to figure out where I'm going. Okay, so then I'll switch over to that. Nice to have gas be full up. Definitely don't want to be caught in a situation where run out of gas when the tornado's going down, as mentioned previously. Okay, so let's pull up the radar again. And boy, what a circulation, guys. This is going to be incredible. Thank you for staying with me for this adventure. I know this has been a rough stream. I'm not the pro at this, but it has been a learning experience. It's been fun, and we're just about to get the payoff here, I think. I believe this thing is wrapping up into a tornado as we speak. So I'm going to apply the pressure here to try to get there as fast as I can. We're not too far away. This thing definitely dove south, so this made it a little bit more difficult for us to get there, but do the best we can. Let me zoom out and show you where we are. So now in retrospect, my decision to run further west, towards Pink and that area, then would have been, a little bit more dicey from a hail perspective. Now we have a clear shot at intercepting the storm. We just got to get there, and that's hard to do, but I'm determined to get there as fast as I can safely. All right, I'm gonna briefly hop over to the chat to see what's up. See my wife on the chat. Hey Morgan. Hey Meredith. Give a shout out to those folks. And I see Eddie. He's down there watching the storm near Weatherford. Awesome. Good point. Storm Crowd just pointed out that the spin and stretch part of this, it's also important to talk about cycling and recycling. That's true. There's something called the rear flank downdraft that comes into a supercell from the southwest side of the storm, basically coincident with the hook echo. It's basically the same thing, and that is what forms tornadoes. If you can push further in a storm relative sense to the east, and then definitely produce another tornado. So that's a good point. All right, I'm going to hop back over to the radar here, and let's see what we've got. Oh my goodness, guys. This is going to have a tornado soon. Oh, it may already have one. Does anyone know if a tornado has been sighted yet? Because if it hasn't produced, it's just about to. And we may get there just in time, because we are not far away. Oh, wow, this is right here, just east of the tornado. about to have a really incredible view, I think. Let me get back on the storm. Yeah, that's a real circulation, I think. Looks like we have another warning. Let me check on that warning text. Radar indicates, so not observed yet. Okay, Maysville. Motion is, let's see what the motion is. East at 35, so it's moving. Definitely was a good decision to go a little bit further east like we did. I'm still struggling to get out ahead of it because it's moving so far to the right. That's amazing. This was definitely not something I had projected when I was looking at the forecast today. Rightward moving storm that's going like, east southeast. That's wild. But here we are. I'm actually here a little bit right around the time I thought I would be. Maybe even a little earlier. Drove in from East Tennessee today, so struggling to keep up with everyone else who's already been here. Actually seeing, I wish I could show you. You know what? I may show you this. Hold on. Let me turn off screen share for just a minute. I will share with you. The actual view of the storm out the side window. Okay, just give me a second. I'm gonna turn it back on. This is wild. Okay. Oops.
Okay. I'm going to do my little picture-in-picture here so you can actually see the storm structure as it's happening. See those inflow bands that are coming in? That's amazing. That is a great sign. So they're coming in from the east and east. So my camera, the front-facing one is going west, I believe, and this one is facing towards the southwest. All right. Well, I'm going to go back to the radar view, but I wanted you guys to just get a good view of what the storm looks like from my perspective. Can't really tilt as well. Okay.
Oh, there's the tornado warning on the phone. I'm going to share my screen again with the radar. First south and just oh my goodness, spreading the bugs here. Apologies if that's getting a little dirty. Okay, back to the radar. Looks like there's a report of a rotating wall cloud. Let me put that on the screen. There it is. Yeah, that is a very good looking storm right there. I like the fact that it's a broad mezzo, so it's not just a little tiny thing. It's got a pretty big expanse. It's over a number of pixels rather than just a couple, and it's got speed. But overall, you can get the sense that this thing is about to produce probably a giant tornado pretty soon, and I think we might get there just in time to see that happen. Let's see, where are we? Oh, we are still quite a bit north. Oh, goodness gracious. Whoops. Sorry. Yeah, that was dangerous. Wanted to make sure that we weren't getting into the core there. This road does not have much of a shoulder. I am going the speed limit though, so there's that. see. Let's go back to that. Whoa, my goodness. I might have to refigure my path here. I'm kind of cutting out in front of it a little bit. I'm hoping I can get to Stratford before the storm does, so you can see me at the top right. You can see Stratford kind of in the middle there.
At the next stop sign, turn left.
If I can get out ahead of it, then we'll get a great view. I think we can, but this thing is not moving slowly. It is not wasting any time, which is both bad and good. Okay. Here's my stop sign. And then go ahead. Got a good clear view. Let me turn off my washer
In about
wipers here.
8.5 miles, keep right
Goodness.
onto US 177.
That doesn't have a tornado. It's about to have one. Gosh, we're so close. So this may be the realization of that 7 or 8 significant tornado print. Over to chat now. See what everyone has to say real quick, and then get back to the radar. Thanks, Storm Crowd. Appreciate that. Eddie says it's still storm radar indicated still. Okay, that's for the Fort Worth one. So you guys can see maybe the inflow bands in front of me. So those are those little like horizontal clouds that you see there. They look really benign. They didn't stretch. That's actually feeding this storm with spin, and we're about to move into that region, and we should be able to see, you know, just an incredible view shortly. Actually, I'm going to turn on my main cameras over here now while I'm thinking about it. It's easy to get really fixated on the stream here and forget that, oh yeah, I can take pictures of tornadoes now. So I'm going to go ahead and looks like we have a tornado. Okay, that's not surprising at all. Okay, so 5:26 p.m. It is now 5:28, so we've had a tornado. We are a little late to the show, but we should be able to catch up. We're almost there. I'm heading straight to Stratford, so I should be in excellent position to intercept this tornado. Just a minute. About to intercept near Stratford. Want everybody to know that this is about to happen. So here comes the rain. You can see I'm about to enter the forward flank of this supercell. And then I'll just have a clear west drive. I'm going to go ahead and modify my coordinate. Double check the movement here though. Okay, yeah, that's moving due east. Actually, you know what? I might just, I might stay closer to Stratford because that looks like that may be hugging that road a little bit. So I'll just go west from Stratford. If it looks crazy, I might turn east. This is the kind of situation, to be honest with you, to get a little hairy because there's probably a lot of tornado chasers there, and there are going to be a lot of people on that road. And if you get too close, then you might have a problem trying to turn around and go the other way to get away from the tornado. So we have to be pretty careful about how we approach this, because that is no doubt producing a substantial tornado at this point. So I'm going to check my coordinates real quick. And it looks like, I'm gonna zoom out. I don't really like how Google Maps does that. Okay, so it looks like I'm a few miles outside of Stratford. 5:46 time of arrival. So it's still a little ways out. It's a 4-way stop, so that's nice. See me there. So I'm in the town of Asher. Again, we can see those clouds just streaming in from left to right. Wow, this is amazing. This is likely producing a big tornado. Let's go ahead and take, not a big tornado, at least on radar, but it looks like it produced at least a tornado. That's amazing. So that looks like it is just northwest of Falls Valley. Falls Valley's had a number of tornadoes. There was that one near Falls Valley in 2016, the Katy tornado, F4, just an absolutely unbelievably violent tornado. I saw the tail end of that one, and then saw a wedge, perhaps the largest wedge of my life near Sulphur, Oklahoma, right after that. So we were talking about cycling tornadic storms, and that was definitely a cycling tornadic storm. So it is interesting. My video seems to be having some issues.
Right, on US 177 South.
Bummed. I'm having some camera issues right now that I can't really deal with. Not sure what's going on. I'll check it out when I stop. 11 miles from Stratford. Sorry, that was my blinker. I was wondering what that noise was. I wasn't familiar with it. Very sharp anvil there. That's a good sign. That just has the observe tag on the warning. Tornado, damaging tornado. Looks like there's some higher velocities there. Where's that? Right. Northwest of Falls Valley. What's the reflectivity look like? Not as good as it looked earlier, but still pretty good. We're now almost in the forward flank downdraft. So pretty soon what we're going to do is we're going to actually get out of the rain and be able to see this thing in its full glory. I'm going to be able to tint to my camera, which I'm very excited about. So we do see some inflow banding there ahead of us. I don't know if you can see that in the view, but right on the horizon there are these little like cumulus type clouds that are feeding into the storm from the east, like the ones that I was talking about earlier. Again, that's bringing in the juice, that's bringing in the spin into the storm, and should have a good view soon. Although, again, us to have a good view from this perspective. Let's throw on the loop. Let's see what that's doing. Okay, so it's looking a little less organized. So maybe going through a cycle. So speaking of cycling, that seems to be happening now. So basically, what I mean by cycling is that the old circulation appears to be dying, and a new one is going to probably take its place. Starting to get a view here out my right window. I can't show you guys just yet, but I'm starting to get some view. So we are finally getting here. Time is 5:37 p.m. We're getting pretty big raindrops right here in this forest. They're like big, fat raindrops. Cycling, so there's a good chance that we'll see another tornado from this. It doesn't feel like the storm is weakening; it just is cycling. Okay, let's see where we're headed. We've got another 6 miles, and then we'll have a view due to the west. And so, once we get to that highway with Stratford, my plan is to take a right out of Stratford and kind of look at the storm as it's coming in from the west. Okay, we're back. I think what happened is we got into pretty heavy precipitation, and Starlink kind of fell out of place. I think we're back now, and we should be back for the duration. So we'll stay out of the rain. Let me throw the radar back on. So just to reiterate, my plan is to turn right to go west out of Stratford. So let me just show you where I am. So I'm right here at the right hand side of the image, and I'm planning to get to Stratford and head west. Although it'll be pretty close to the hail, so maybe I will retreat a little bit. I'm a little worried about hail. This is not my vehicle, so I think I'm going to be careful to make sure that I don't get any hail dings. So, but I'm starting to get some view of the structure. So this is excellent. Oh wow! Can't wait to show you this. Tell you what I may end up doing, instead of going west on Stratford, that would normally be my big move, but I've got some camera work to do. So my plan is actually, I think my new plan is to drop a little bit south of Stratford, and then we'll see about a road to head west, maybe get closer. We're in a 4x4, so that should be okay. Let me take the radar off. I'm going to go ahead and kind of peek around for the opportunity to chase a little closer. But I want to go a little bit south of Stratford, so I'm going to see what road options I have. Looks like there is a road called 177. I'm not sure what the scale is. Let me zoom out. It goes out of Wynnewood, so I'm going to check that out and see what that looks like. Okay, that's a little too far south. So probably the best move is literally to maybe just go, let me put the radar back on. So drop south out of Stratford and just let it come our way. Oh yeah. Oh, this thing has incredible structure. Wow. That is wild. Guys, I can't wait to show you this once we turn to the west. That will be here in a couple minutes. This has tremendous structure. Let me check the chat real quick. it's down. I'm going to go ahead and check out the post and see what we're missing. Okay, nice tube. Actually, I think I might have an opportunity to head west towards Stratford, so I think, or head west from Stratford, excuse me. You can always retreat south, so I'm going to take a little bit more of an aggressive maneuver here, just because I want to get some good shots, and it won't be too aggressive, but just enough to get a good view for you all. And I don't think it's moving terribly fast either. Okay, we're about to make our west turn. Here it comes, guys. Some good lightning in this.
Turn left.
Turn that off. So got a new tornado warning. Let me put that on the screen here. Here's the storm. Look at that skeletal structure. So probably what I'm going to do is find a spot to just kind of pull off and let it come our way. That's incredible. It's just a nice, skinny LP type of supercell. Looks like the core is going to stay just north of the road, so that's good news. Looks like the main wall cloud is directly ahead of us. So let's get a little closer. Oh, this is cool. Oh my goodness, guys. This is wild. We're about to have a tornado. This very skeletal structure. It's like almost like an LP. Wow. You see all the cars coming this way. Wow. I think I'm going to probably pull off somewhere up here. See if I can find a good viewing spot. Oh wow, that is some kind of motion there. I want to get a little bit closer to that. We can get some wide shots. Looks like there might be some spots there. A little tough to see. I'd like to get a little closer so we can see the ground. Wow. Goodness. Wow. Okay, here's a view. we're back. It took 10 minutes of problems with hail. Plan is to just get a little bit east and south so that we can get out of the way of this thing. Don't want to get any hail. Playing it a little bit too fast and loose. Did see some good structure, so I'm going to try to retreat and see what we can see. Well, try to die another day. Let's see. No, that's not a good one. Might be a good spot. Okay, I'm going to turn around here. Maybe. I don't really see a pole out there, so never mind. So I think I'm going to stick with my original plan. I'm going to go to Stratford and just drop south a couple miles and let this thing come towards me. I think that probably would have been a better choice. It was kind of nice to take a look at the storm from a closer perspective. It is moving at a pretty good clip, so... So much for Starlink having no lag. It seems that this is good outside of the storm, but inside the storm it's atrocious, so it's kind of the opposite of what we want. But looks like we're getting a better view here. That's nice. One that doesn't involve potential for hail. So I see the wall cloud. I'm going to go just one more mile south so we can get definitely out of the path, and then I'm going to find a view. So it definitely doesn't look quite as good on reflectivity as it did earlier. Hoping for the people here that it won't be problematic for them. Although I do see a big, potentially truncated cone funnel developing. So let's see. Oh wow, that looks interesting. Okay, here's a good view. Maybe not far enough south, to be honest with you. Oh, yeah. This thing just kind of dips. Move this out of the way so you can see the circulation. So right now we are near Stratford. So we're starting to get a view from there. Nothing. This terrain is awful. I might turn around. But let's see. Found the one place in Oklahoma that has like trees like Tennessee. here we go. Let's see. I could park there. That's not a very good spot to park. A little further. This thing is getting stretched out a little bit. So I think we're okay to get a little closer. Goodness, that's the end of the road. All right. All right, folks, I think I'm going to do the other direction. This is not looking nearly enticing enough to stay on a dead-end road. Doubt whether maybe... This day. I've had some delays that kept me from getting here on time, which is unfortunate, but that's just the way the cookie crumbles sometimes. Missed the tornado by about 20 minutes. Alright. Okay. Well, it looks like we tried to point in that direction if I can. We'll see. Oh, yeah, that looks a lot better, actually. How am I going to do this? This is a madhouse right here. There's really no shoulder. There's a very big road. Oh, shoot. In a faster... Let's see. I'm going to join the masses here. You coming, man? Go ahead and do this. Get a good view of this thing. More. So let's see. Basically, what does it look like? The clouds are coming in from the north. Not sure if this has one more in it or not. But I do see a pretty substantial circulation, like dead ahead. Get out and watch it for a minute. I think I'm gonna get out this camera. I think we might be getting a tornado forming in front of us. Let's see. I don't know. You know what? I'm just gonna keep it on the... always go east, but I'd rather use the highway. It's much easier that way anyway. Cobwebs a little bit from my previous unfair, sir. Okay, I guess I'm going. Please help. Off a couple miles just to get some space on the storm. Gotta watch out for chasers here. I don't think these are like regular chasers. These are everyone else. Everyone else. That's awesome. The biggest chaser convergence I've ever seen. Wow. Oh, that's better. All right. So I turned around. I was a little too close, but I think this is like the right distance from it. And try to get to the top of the hill. I did not want to be in it, you know. So this is ideal. So it looks like the main circulation is just a little left of the road based upon the reflectivity signature. Well, this is where I'd like to stop. If I can. Okay, this is where I'd like to stop. If I can. Goodness. It's hard to find a spot to stop. Okay, it looks like there's some pretty good rotation. It's hard to find a spot to stop. Okay, it looks like there's some pretty good rotation over the road. Hey. Can you hear me? Well, it looks like I'm back on the stream. Okay. Well, that's nice. I guess we're trying again. Just the very best spot to watch a storm is just atrociously busy with folks. So I'm going to try to do something different. Zig while everyone else is zagging, because this is not the most fun to kind of fight for space with this storm. Oops, that's the wrong direction. Sometimes it's like this out here. It's getting more popular, which is a good thing. Okay, let's see what we got. Okay. So it's off to the left here. Point there as soon as I can. Oh wow, this is looking a lot better on radar. Let me pop this back on the screen. Just trying to decide whether, yeah, I probably better turn right. This thing is definitely diving to the southeast, which must be increasing the shear. There's no rain, so I don't need that anymore. Oh goodness. Even the side roads have a lot of folks on them. Glad they got the 4x4. Not going to be great if it gets wet, so definitely want to stay out of the wet. This is where getting a 4x4 pays off. I'll tell you what, I would not dare doing this in a sedan. It's got a little bit of gravel, but man, this would be pretty sloppy, I think. Okay, I think we're about to the, yeah, here we go. I'm gonna turn left here. Should get a good, maybe I can position for the long term. You guys can get a better view. Oh my goodness. Chaser City. Well, maybe there's a chance. We've got some time. I mean, it is only 6:23 p.m. Okay, let's see. It's not even prime time. Oh, okay. Doesn't look amazing yet. So no need to pull the camera off the camera. There I go to the stream to find out if anyone's still on. I know a lot of people lost me. I'm gonna go check it. Say hey if you're still on. Hey, it's a Philly thing. Awesome. Well, we've gone down in numbers. That's okay. But yeah, I'll just keep chasing this as long as I can. It's looking okay. Still struggling a little bit, but I'll get back to the radar here. Okay. Oh wow, that walk. Oh, something's coming together, guys. Something's coming together. I like this. There's an RFT. Let's see. I may turn to the north, to be honest with you. I may turn to the north. And to me, that looks like the harbinger of a tornado developing, potentially. And I want to get a little closer because I'm a little far away. So, you know, I retreated to get away from all the nonsense, but it looks like we were going to be able to go north. This thing has slowed down a little bit. It doesn't seem, or maybe it's just my perception. Gosh, a lot of dirt here. Ooh, that's a nice looking wall cloud. We're going slow. Okay, well, when we turn north, which will be in very short order, yeah, I mean, it's in the right. Oh, actually, that does look amazing. My main camera. Hopefully, that's tilted up a little bit. Yeah, that's. Yes, I am definitely turning that way. Yes, sir. Left, left, left. Let's go. I think it might be going. You see that? There's some rotation in that. We'll come in behind it. Starting to consolidate a little bit. This is the moment where I like to play a little bit more aggressive time with it. Because they're usually really... It's been a little hard to chase this with so many different chasers around and bad terrain, to be completely honest. So if we get a tornado, I'm going to feel pretty good about it. And all 14 of you can rejoice with me. Boy, I'm eating his dust. Oh boy. Well, we are right there, for what it's worth, right behind this circulation. I'm not seeing any ground contact. Move this radar out of the way so you can see the whole thing. Oh wow, big freaking wall cloud to the east though. Oh my goodness. Okay, so this is getting a little bit more interesting, especially to the east. So we're gonna just kind of meander that way. Don't like being west of the storm, but I will say that it's eminently preferable to being in the middle of the thicket with all those chasers. So we'll go to the east because there's a lot of rain up here, I'm sensing. Just avoid getting in hail and so forth. So I'm going to take a right turn. Oh, you've got to be freaking kidding me. Oh, this must be a cop. Yeah, see that? Big old wall cloud. I don't know what's going on there, but it's looking interesting. Activity structure doesn't look amazing, so I'm not, that may just be happenstance to look nice. Okay, this is like hook echo precipitation. Okay, and then the road meanders some more. Bob's Road over here. Bob's Road. Got like a fake cop ahead of us. That's why. Okay, so this thing's starting to get past us a little bit. An appetizer, I'm just kind of being a little bit more aggressive because one's pretty good circulation up there. These folks are trying to go the other way. It's not a bad idea. It's not a bad idea. This thing is, let's see, what kind of, dang it. Yeah, I'm not really sure that we're going to be able to get out of the way of the hail. You know, I might just do the same thing. In fact, I'm gonna. All right, well, I tried, but this thing, it turned out that it went to the right even more. So I'm gonna just pull a nice little T-turn and get out of here and die another day. So let's try it again. This is more like, so let's try it again. This is more like a whatever is a zigzag turn. I don't know, but okay, we'll catch up with this. Okay, all right. Okay, back to business. Definitely don't want to do that road. Not with the hail. My object. So I'm gonna do a tactical retreat 1 mile to the west, and then we'll drop south and then head back east toward it. I'm getting a little bit behind it, which is unfortunate, but I think it's not moving fast enough that we'll lose it. But matter of fact, I think this thing might be dying. So let me put that. There's the radar. There's me. I don't know. This storm is just kind of air, and then we will try to catch up with the storm. Honestly, there wasn't a really good option because all the pavement was right like in the core of the storm. So it's just, you kind of got to deal with the hand that's dealt to you. Definitely looking forward to tomorrow. This is it's kind of complete nonsense, to be honest. Okay. Wow. Well, actually, now that I've made fun of the storm, it actually looks amazing. I'm going to have to drop a little bit further south, I think, because that's just not going to work. But trust me when I say this thing is looking crazy. Like, actually, let me see if I can get you a window shot. That'd be nice. Wow, that is pretty. Take this screen full once I'm ready. Look at that beauty. Quite a bend. next option here shortly, which is nice. So this, we can catch up with it. Pretty nice clouds, I will say. Still a tornado warning. I will say that, I mean, the storm still looks like it has pretty good scale. Or the storm is big, let's say. And I guess big is good. You know, it's not bad. I wonder what it looks like underneath there. Gosh, this road is... wild. Well, good to shake off the rust a little bit. Planes chasing. Got a big day tomorrow. I would say there's a good chance that we'll get a moderate risk upgrade tomorrow. I doubt a high, but moderate seems very probable. So, strong tornadoes. Just behind the storm right now. So is everybody else, except for those who were like right next to the rain and hail core, which of course I didn't want to do. Uh-oh, looks like there might be a developing tornado. Can we get there? I think so. Don't see any correlation coefficient, so wow. It might be a fake velocity. I'm not really sure. But we'll see. Could be a real deal. Looks like we're catching up a little bit. It's moving east southeast, so you know, I'm tempted to. Okay, we're on pavement. Yeah, it looks like there's a nice road up ahead of us. I think I'm gonna just zip up to that one and then catch up with it that way. Still in chat? Oh, okay. It looks like there are a few folks here. Yeah, so, oh. Yeah, the feed isn't too stable, you're right, Tim. It's unfortunate. I think, so I'm finding out that Starlink is great for planes, not so great for the woods, which is what we have here, which is why it's cutting out and it's not too stable, which is unfortunate. I'm hoping that tomorrow will be in northern Oklahoma and southern Kansas, so our fortune should change, which is good. Let's see who else. Laura says, what's the best way to monitor hail? I'd say the best way to monitor hail is to look at ZDR. So I think we talked about that briefly in the course, But CDR is differential reflectivity, and basically it measures like the shapes of hail, or hydrometeors, and you know that rain is a kind of a pancake shape, whereas hail is more circular. And so it turns out that low ZDR, and I won't go into all the reasoning for it, but low ZDR and high reflectivity is associated with large hail. So if you look at the combination of, like, say, 55 or 60 dBz with ZDR near 0, then you have some probably pretty big hailstones in there. And it looks like we have a little bit of a chaser jam up ahead. Surprise, surprise. Let's go follow the masses, shall we? I tried to get a little cute. That did not work out well for me, unfortunately. Oh gosh, this is not... I don't actually... maybe I'll go right. Let me put up the radar here and I'll show you what I mean. So, that looks like fake velocity. In fact, I think this may be starting to bow out a little bit. Yeah, we're definitely turning right here. Because that's moving. That's definitely moving to the southeast. And I don't want to get in the hail. So, ooh, there's some sweet clouds up here. Awesome. Oh, okay, you can kind of see the... oh, nice. There's a little bit of a wall cloud off in the distance. I wish I could show it to you, but it is so treed around here. Yeah, that velocity looks wonky. I don't know what's going on there. Yeah, blocking line of sight. That's right, Tim. Yeah, it does seem like they may be tightening up a little bit. I can't really tell if it's fake velocity or real. I guess we'll find out, because I'm about to get a view. I'm getting to that road that goes towards like Fitzhugh. If you see that, let me pull that back on radar. You'll see what I mean. Stonewall. And I guess there's a shortcut to get there. Shortcuts have been working really well for me today. I'll tell you what, it has not been my best chase day. This is why you need a partner, folks. Tim, my old chase partner, is in the chat here, and he's been offering some good thoughts. Wish you were here with me, buddy. But, you know, chasing's not easy. Really, it's hard when you have a lot of folks, and I think that's really the issue. We had a lot of folks, dangerous storm, and hail, and I didn't want to mess with any of them, so we kind of took an alternative route, which, you know, all things considered, not the best route. But you kind of have to play the hand that you're dealt, and that's what we did. But I'm gonna get a little aggressive here and try to cut across this road to the east. Instead of getting on the highway, I'm just gonna go straight east. I think this guy ahead of me is gonna do the same thing. Sorry, this is shaking quite a bit. Really not much I can do about that. These roads are abysmal. Okay, here's our turn. So this is our cut across. This will get us to the main road, and this will actually put us in really good position. Oh, it looks like it's nice. Is it paved? Yes, excellent. There is no greater chaser thrill than trying to play catch up on pavement after you've been in the gravel for way too long. This is good. This is good. Here we go. Man, these hills reminds me of home, Tennessee. I think my wife and her sister are watching this in the hills of Tennessee. Well, this is the nice prequel to tomorrow's action, so I think tomorrow is going to be off the chains. It's going to be one of the biggest things that has been in the plains in a little while, I think. If it all goes well, I should say. You know, there's always flies in the ointment for for every setup, and I always preach that, but sometimes I get really excited, just like just now. The truth is, you don't know. You don't know. You can get all the ingredients, and tomorrow has an excellent shot of being a big day. So exciting to see my parents. And that may actually happen sooner rather than later, judging from this this road. This is going to need a car wash before tomorrow. My goodness. Everybody else too. You see this guy ahead of me. He's got. Hey, I don't know if you can see through his windows at this point. Miss chasing, guys. If this were me, having lived in Oklahoma and gone chasing like this 8 years ago, I would have been just miserable and sad for making choices and all sorts of things. But you know, as it stands, I'm having a blast. This is a fun time. It's not the best storm, but it's nice to get out here to be in Oklahoma. And we're about to catch up to the highway. That storm is just looking pretty pitiful. It's interesting because it does have like a nice shape-ish, but like, I don't know, velocity just looks super weird. But I don't know. Stranger things have happened. So, you know, and it's only 6:48, right? So, low-level jet should be kicking in. Magic hour. That's another chase lesson if there is one for you. Don't give up too early. Wait until it's dead, and you'll know it's dead when it starts to shrink. And this is not shrinking. This is a big storm. It's a pretty big storm, and that has a chance to fight the cap and stick with it for a little bit and potentially produce a tornado. We'll see. No steak dinner for me tonight, I'll tell you that. Decisions were made. So for those of you who don't know, steak dinner is associated with big chasing wins. Some snafus earlier in the chase where I had to diagnose some problems with my internet connection, which ironically is still happening. So it is what it is. You have to deal with that sometimes. All right, we're getting close to getting a view. So let's see what this looks like. It's kind of wrapped up a little bit. There may be something about circulation up ahead of us, but we're a ways off. Yeah. Oh, it might be actually getting its act together. That is wild. Okay, I can see. Yeah. I mean, that looks legit. I don't know if there's any. Let's look at, correlation coefficient. I don't see any low CC. That circulation is. So if you look here, there's the circulation, right? So where that is, and let's go ahead and double pane that, right? And we can look at correlation coefficient, and then we can do the little gizmo here. Look at that. Well, maybe there's some low CC there. There's a chance there might be a tornado developing right there. So will we have a chance to catch up with it? I hope so. So I'm going to back out. Yeah, we're a minute away from this, and lots of folks chasing this thing. Okay, looks like, oh, that's interesting. So you see that? As far as I can tell, the red box did not go further. So I'm thinking that the National Weather Service in Norman believes this is a fake circulation. Which, nice ramp up to the velocity. I bet you if we looked at spectrum width, it would be pretty crazy. That's not too bad. I don't know. Trying to analyze this in real time is tough. Anyone seen anything from feeds out there that show that this is worth chasing further? And check the comments in just a second. It does look like it's kind of growing up scale a little bit, which not great, but all right, back to the feed. If you feel it, Jason, I love it. Tim says it's moving east, not southeast. Appears to be wrapping up. Yeah, you do. You do need somebody to focus on the driving part. This has been really hard, to be honest. I'll have that tomorrow, thank goodness. So you're right, Eddie. That was my preference. Unfortunately, you have to do what you have to do. The road, paved road, heading towards Lawrence, Oklahoma. So we're talking about tomorrow. Yes. Thanks, Smitheries. I appreciate it. I'm having a fun time here by myself. It would be great to have some friends along, but you guys are my friends, and it's been great to have folks here to talk to while I'm trying to catch up to this storm. All right, let's go back to the storm. It does look like there's some velocity there. I don't know what to make of that. Feel free to comment if you think it's interesting and think it's worth chasing. Actually, I do think it's a bit of an interesting structure that's starting to pop out of the rain a bit. Let's see. I'm gonna plot out my course to get closer. So, unfortunately, this is southeastern Oklahoma now, so it is looking a little bit harder to chase this thing, and so I'll chase this as much as it seems practical to do so. But it is tough noogies to find roads around here that aren't windy and gravelly and just like the ones we had earlier. Give me northern Oklahoma tomorrow. I don't want to do this again. I will say this is definitely better than where I am from. So Tennessee will be. This is at least a view, which is better than no view. So we'll take it. Honestly, this looks a little bit whale's mouthy, which just means that like there's just a lot of outflow, not a lot of inflow, but I could be mistaken. For sure. So let's see what we got here. Rain. That's the report. I might see about the environment here to see if this is worth chasing further, because once you get to this point, to be completely honest with you, doing an assessment of whether it's worth it to continue chasing, especially since tomorrow is going to be a big day and you don't want to wipe yourself out, right? So that's part of chasing, being strategic. And to be honest with you, I am inclined to maybe let this one go here soon. This is pretty far away from where I'm going to be staying tonight in Norman. So let me give it a second look. Yeah, that's just getting so messy. Any thoughts in the comments about whether I should stay with it or let it go? Oh. The old chase partner says bail. Bail. Let's see what everyone else says. I am thinking bail too. And thanks. It's a Philly thing, and Big Mike. Yeah, that's a good way to feel about it. Okay, things are starting to light up near Pampa. Okay, wild. Well, folks, I hate to say it, I think road options, and the storm doesn't look great, and so I really appreciate y'all joining the stream. Sorry it was in and out. Hopefully it'll be a little bit better tomorrow, as we'll be in better terrain. And also, I'm starting to get used to this new program. This is my first time streaming, so thank you for bearing with me while I try to navigate that. I'll be better tomorrow. I'll have a chase partner, and my driving will be much better than it was today. Recommend chasing with somebody. But thank you so much for joining the stream, and I will catch you on the